I want you to start using your yellow sheet like more regularly as a reference, like having it out while you're doing your homework and stuff, and like being able to identify what chapters or which bit, trying to get toward that AP exam type situation. I want you guys to add this bit. Now the center and spread's kind of obvious. I mean, you could skip that because clearly we wrote it above. Unfortunately, updating the yellow sheet right now is going to cause you some spoilers for our lesson today about standard deviation. Yeah. I don't know if you see the spoiler there. Mhm. Other side, other side. Stop boxes, stop boxes. So this is what we've written over the last couple days. Uh, so, when you take the AP test, you won't have special things written on there like this, but I'm hoping that by having these written there for 6 months prior, that they will just like appear to you. That's my hope. You think they will? Yeah. I will hope. I'm gonna remember. Yeah, I don't know. Trying real hard. Also, guys, these notes are going to feel a little bit repetitive. And I want to apologize, except for that I think that that's kind of refreshing, just because you'll be confident on what to do. There's nothing wrong with being confident. So I'm sorry if it's a little repetitive. It's like shape, center, spread, write a sentence, shape, center, spread, write a sentence. I know, but that's okay. Just means that you're getting it. Okay. Last thing I do want to apologize for is that when you have two populations in a problem, it's kind of annoying. So that's, it's not a big deal. It's just a little bit, not a little bit, it's kind of mildly annoying. Okay, are you guys set with the yellow sheet updates? Okay, so don't put that away, just slide it off to the side. Okay. All right, so let's just make sure we understand this sentence. Many studies make comparisons about two populations by finding the difference between the same statistic from both populations. I want you to think about this being like a matched pairs experiment. Do you guys remember when we did matched pairs? It was like your hand reaction time, and then you did like the first treatment, so you did like your dominant hand, and then you did your non-dominant hand, and then they subtracted. Do you remember we found the differences? Okay, so this would be like an example would be some kind of matched pairs experiment where you did like the proportion of words typed correctly with caffeine, the proportion of words typed correctly without caffeine, and subtracted, something like that. Okay, it's not a big deal. It's more just like recognizing when you have two populations from the word problem itself. So here we go. Sampling distribution of p hat 1 minus p hat 2. Actually, I really need to make sure you understand what that's saying. Okay. Make sure Mrs. Talbot at her dining room table with the M&Ms. Do you see them? There's stacks of them everywhere. Actually, you really can't stack them. They're kind of slidey. I don't know if you've ever tried to like have a pile of M&Ms. They don't stack. Okay, anyway. Okay, so I buy a bag of M&Ms from Target, and that's over here on my side of the dining room table. And then I buy a bag of M&Ms from Walmart, and it's over here. And I'm thinking that Target's gonna have more blue ones than the Walmart one. Maybe I should have said a different country because that would have made more sense. But you get what I'm saying. They're two separate bags, right? So I go over here and I do a sample of 20 and I have it in Dixie cup. And I go over here and I do a sample. By the way, my dining room table is not this big. I'm just trying to be adorable. So, and I get a sample and I take the proportion of blues and subtract. And then I plot that dot on a dot plot. So it's not two dots. The subtraction happens first. And then I plot that dot. You guys see what I mean? So I've got like 0.15 from my target, and I've got 0.20 from my Walmart bag. And I go 0.15 minus 0.20 is negative 0.05, and then I plot that dot on the dot plot. Okay, so the subtractions happen first. Also, negatives can happen with these because that makes sense when one is less than the other. Okay, does that help? It's not like two dots. You subtract the two proportions and then plot the dot of the subtraction. Okay. Why it required me to run all over the front of the classroom, I don't know, it just did. Okay, so the shape of that dot plot. Well, what do we do for shape when it's one population? Flip back if you need to. What do we do for shape when it's one population? Check the graph first. And then large counts condition. Okay, here's the bad news. There's two populations. So you have to check the large counts condition twice. Oh no. Okay. Please listen. This is what I was mentioning before about when you have two populations, it's kind of annoying. It's not a big deal. Like, you can multiply two numbers and decide if that's greater than or equal to 10. But I'd rather do it 2 times instead of 4 times because, lazy. Okay. Now, regardless of shape, what should the center of the dot plot be? This, right? So the center of the dot plot, remember, this is creating one dot each time. I subtract first, then plot the dot. Should be the true proportion of the first sample. True proportion of the first population minus the true proportion of the second population. So in theory, the Walmart bag minus the Target bag should be 0. Does that make sense? If you get 0 for this, don't be weirded out because, yeah, they should technically be the same. Oh, I don't know about other countries and their M&Ms, but anyway, okay. Yes, honey. Okay, now here's the other annoying bit for spread. I spoiled it on your yellow sheet, but you have to check the 10% condition twice. It has to be both samples. And if they both do, then you can use the formula. Mhm. So here's the thing. It's never not going to work unless you're being asked a question about whether or not it works. Okay, so if the homework or quiz or test question is asking you, does this satisfy the 10% condition? It will be yes or no. But if they're asking you to verify and then find the spread and then use that to find probability, it's always going to be yes, because you got to keep going. It's kind of a difference between an MCQ and FRQ situation. Like in an MCQ, they're going to be like, oh, does this meet the 10% condition? But then on an FRQ, you're not going to like stop in the middle of it and be like, nope, I'm out. It's then leave the whole paper blank. That wouldn't make sense. So anyway, I was just setting up my notebooks for chapter 8. I know I'm a weirdo. I don't want to try to take as much home over Christmas break as possible, but there is a set of notes, not a whole set, but a little section where we talk about what happens if the conditions are violated. So what it does to the actual statistics.
Oh my God. We got over the school on young. Yeah, no. I was one of the things. I had boards and I get my, where you missed me.
Probably not on a diet, because I never over 800 like that. And every single thing I was talking about. Yeah, they go pretty Mostly.
I guess it would be.
I know. I thought of it. I know. I was like, I put on.
I face her in So he'll be like down there. I'm like, I start laughing and he goes, like, really? What is?
Like, did you want? I went there just
Why, Mrs. Talbot, do all of your problems have to be about food? Oh, no. Starving. Do you guys like the colored goldfish ones? I like the flavor blasted cheddar. You like the colored ones? I also like the plain ones, but I like to put them in the soup. Oh, we have a lot in common. What's wrong? What's wrong?
Without.
Are you guys making comments about my eating? Oh,
You are the different things, I need for you to share with the group. I didn't say.
You wonder are we.
You have to stop.
This is yesterday. Unnecessary.
hey, hi, let's do this. Now this is the bottom of the page for me. I don't know if you can fit. I think I used the top half of the second page. You can keep going though. So if you write smaller than me, you could probably fit more down here, but it's up to you. C requires a lot of space. That's why I put it on the top of the second page. Okay. So before we begin, I need you to know that problems like this and problems like the ones in the homework you just did are going to be mixed together at the end of the chapter. It's really important to me that you're able to identify which one set of the formulas you should be looking at. So when you read this, I want you to be able to say to yourself, this is a difference in proportions. Two proportions. Okay, can you tell that there's two populations? Can you tell that it's proportion? Meaning that there's percent. Okay, and you're thinking to yourself, well, what else could it possibly be? And the answer is means. So you're going to have to distinguish between working with proportions or means. I think in this case, they gave you percent, so it's easy. Okay. What is the shape of the sampling distribution p hat 1 minus p hat 2? I don't have a graph to look at. So that means I jump straight to large counts condition. And I'm only writing that there because it's notes. You're not required to write that. You don't have to put it. I'm going to really make sure you guys are not messing up the 10% versus the large counts. Okay. So for bag 1, what is N? Bag 1 of goldfish. What's N? 50. And what is P? Mm-hmm. Okay. What is N for bag 2? 40. You guys just chatting right through the lesson. You know this already? What is P for bag 2? Are you guys okay with if I steal the numbers from already doing this before? Okay. So this is 12.5. This is 37.5, which makes sense because they have to add to 50. This is 14. And this is 26, which makes sense because they have to add to 40. Okay. Any questions about the shape? Okay, find the mean of the sampling distribution. Mean is the center, which is this. So the mean of the dot plot is P1 minus P2. P1 is 0.25. P2 is 0.35 equals negative 0.1. Don't freak out that there's negatives. Remember, we're doing differences. It just means that there's more red ones in bag 2. Not a big deal. Any questions before we move on? You guys good? You sure? Okay, I'm gonna flip my notebook over, but I have this much room. If you guys have more room than that because you write smaller than me, you could probably fit C and maybe D. So the interpretation sentence is gonna be a hot minute. Like you might want to just get out like your scroll or your letter or your Santa's list. Like it's not a small sentence, I'm saying. Great. Okay. 10%. We have to do that first. They always put it at the end of the directions, but it should be at the beginning. Okay, we're gonna start with N1. So that's bag 1. What was the sample size in bag 1? 50. Okay, we're just going with it. You can sit and ponder if there's 500 goldfish in bag 1. Don't care, moving on. Delicious, delicious goldfish. There's probably less now after I got a hold of it. And if there's 500 goldfish in bag one, there's probably 400 goldfish in bag two. We don't care. Moving on. All right. Now we get to do the standard deviation. Oh, fun. Okay, so remember your formulas right here. And it looks just like the formula from last night. It's just that you have to add it together underneath. So it shouldn't be like that wild to you. Okay, so bag one, that one was the 0.25 one, right? Okay, so 0.25, 1 minus 0.25. And there was 50 in bag one. And then bag two had 35%. And I took out 40. I feel like these standard deviations all kind of have the same answer. I don't know if you noticed. There was one in the homework last night that was 0.097, I think. Okay. I don't know if you noticed the amount of lines that I left for the interpretation sentence. Yeah. Just if you have your extra hand with you, you might want to put that on now. Okay. Let's use common sense. We're doing an interpretation sentence. What should come first? Okay. So this is kind of where you're going to realize how annoying this is going to be because there's two populations. Okay, so over many. Okay, does that make sense so far? Okay. I'm going to underline this word that I wrote poorly. Okay, and here's the other annoying thing about um, differences. You have to say which way you subtracted. Because you could subtract bag one minus bag two, or you could do bag two minus bag one. So you have to specify. Okay, but is any of that really shocking? I feel like you could have pieced it together if I had asked you. It's just annoying. Okay, last thing for the day. It's just a normal CDF. However, I'm going to make a little note about inequalities. So it's one line with an extra little note about what to do when you have a difference in inequality. I guess I really had an extra line before D, but. Oh, yeah. Yeah. Cause it wouldn't make sense logically with the double or. Like if you're following it, yeah. I like to go this step, but yeah, me too. You can start with one conversation. That won't be a waste. Problem solving over here. Yeah, for sure. Life or death, life or death.
I didn't think that.
Okay, so, I am going to do something on a post-it note over here. And, I'm hoping it will help your brain here. So I'm gonna use some math. I know. I'm gonna use some math to help you with your stats. Crazy talk. Okay, guys, shh. Okay, so don't write this. This is just me trying to activate your prior knowledge of algebra. Okay, so if I have x minus 6 is greater than 0, and you're in math 1 class, what would you do to get x by itself? Okay, so would it make sense to you? Is it fair then if I started here and I wanted to go backwards to here, I could, and you wouldn't ever do this probably, but in math, in stats, you will in a second. Would it be okay? Would it be legal for me to say this? Okay, so if I started here, added 6 to both sides, and got this, would it be legal to start with that, undo the 6, and have this? Yes, okay. Just wanted to verify. All right, so what I'm saying is if I read the question, it says, find the probability that the proportion of crackers in bag 1, so proportion of crackers in bag 1 is greater than the proportion of crackers in bag 2. We do not know how to do a normal CDF where you're finding where something is greater than something else, unless one of these is a number. We know X is greater than 3. We can do that for normal CDF. We don't know how to do like 2 things. Okay, so what I'm suggesting to you is instead of this, that's wrong. I already wrote it wrong. Because I'm excited. Write it like this. Okay. Do you see what I did? I minused p hat 2 from both sides. Okay. And I minus p hat 2 from both sides because I actually have the mean and standard deviation of this
and I can find where this is greater than 0. Okay, so normal CDF. Okay, ignore all of this crap. What do we do when it's greater than 0? So what would the low be? 0. What would the high be? 10 to the 99. Okay. And then now you think, okay, I need the mean and standard deviation of this, which is what I calculated in problems B and C. So in B, the mean was negative 0.10. And the standard deviation was 0.097. Does that make sense to you guys? Because you got the subtraction here, so now you're looking at that as one thing. Okay, so that comes out to be 0.1513. Which I don't care for you to calculate right now, but do you see the transition from here to here? Making us able to plug things into normal CDF then. Okay. I have 2 jokes for you today. I know. One of them is kind of Halloween related, and I should probably put it at Halloween, but one of them is definitely Christmas related. Okay. All right. Okay. These are the actions of evil, which would be funny if you're a history person, but anyway. It says the scatter plot is dripping blood. The data revealed that angry man. A trend that developed towards major campaign. And then bimodal distribution of vegetable theory. There's that. Okay, now this one. Just take a bar graph between the amount of pause and wow. Do you get it? Wow, 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 wow. There's lots more laws than pause. Yeah. You're gonna. Just tell me.